One of the most important features of almost any programming language is the ability to perform mathematic operations. C# has the capability of performing the four basic arithmetic operations such as plus, minus, times, and divide, but it also has several others that will assist you in your programming endeavors. Because we're talking about mathematic operators, most of what we're going to demonstrate here is going to utilize a numeric value type, such as integer or the int data type or double. Let's start working with an int. We'll define int x and we'll set that equal to 10. Then we'll say int y is equal to 5 and int z, we'll just define it as such. We'll assign values to it shortly. If I wanted to add x and y together and assign that value to z, I can simply say z is equal to x plus y. And the same goes for the other three basic math operators. One thing that's different between standard math that you write on a piece of paper and what you see in most computer languages is that the times is represented by asterisk and divide is represented by forward slash. Plus and minus are just simply the plus and minus characters. Like other languages, C# is not fond of dividing by 0. So if y is a 0 and not a 5, as it's shown here in this example, that would throw a divide by 0 exception for integer value types. So int, short, long, all of those will yield a divide by 0 exception if y is 0. It is also possible in C# to do something called overflow or underflow. That is where any of the operations can yield a value that is outside the range of the data type you are trying to store it in. An int can hold a value between -2 billion and +2 billion. However, if let's say the value is already 2 billion and you multiply it by 2, then the answer is going to be well outside the range of an int. Normally you would expect this to throw an exception. However, C# is by default configured to do something called silent overflow or underflow, where it'll simply wrap the value around to the negative side of the value spectrum. If, for instance, we had int m is equal to int.maxValue, and then say m++. Let's put a breakpoint in this code and run it just so you can see what x is going to be. If it's already at the maximum value, yet we add 1, it's like having infinity and adding 1 to infinity. What actually happens? In this case, you can see now m is equal to -2,147,000,000, etc. It didn't give us an exception. It just silently allowed it to underflow or overflow in this case. We could also go the other direction and say m minus minus, which should wrap it back up to the max value. So now m is 2 billion, plus plus makes it -2 billion, minus minus will put it back to the +2 billion again. I'm just leaving off the rest of the digits so I don't have to say the whole thing. So this can be problematic if in your programs you actually want to detect such problems. In that case, what you would want to do is put this possible problematic code in something known as a checked section or a checked block. Now if we run the code and force an overflow, now we get an overflow exception. Alternatively, you could configure your project to always check for underflow and overflow by going to the properties of the project. You can double click on this wrench properties entry in the Solution Explorer. Go to the Build tab, select Advanced, and then select Check for Arithmetic Overflow and Underflow. If that's checked, then we no longer need this checked block anymore. However, if we did have that set, we could make this an unchecked block, and then it would once again allow overflow and underflow within the code. Let's take a look at another mathematic operator. This is known as modulus. Modulus is essentially a divide operation, but it returns the remainder if in this case, the divisor does not go into the dividend evenly. So if y doesn't go into x evenly, what's left over? Well, 5 does go into 10 evenly, but what happens if y was instead a 3? Well, let's put a breakpoint here, and let's see what the value is. So we run, and then we get to this breakpoint, and you can see x is 10, y is 3 at this point. If I hover over y, that's showing me x divided by y. Well, we can fix that. We can go to a watch and show x and y as two separate statements. So x and y are 10 and 3 respectively. And let's see what z is equal to after we step over the statement. Now z is equal to 1. Why is that? Because 10 divided by 3, 3 goes into 10 evenly 3 times. That makes 9. There's 1 left over. That's why the answer is 1. So this will yield the remainder of a divide operation. Be aware that divide and modulus are some of the slower operations, so you should use those sparingly. I've already glossed over these expressions before, but we have the plus plus expression, or the operation, which augments x by 1. Notice here I have it presented two different ways, where the plus plus or increment operator is after the variable x, and I have another one where it's before. The technical terms for this would be a postfix operation and a prefix operation. Postfix being the increment operator shows up after the variable, prefix is when it shows up before. There are many arguments and discussions out on the internet about which of these is most appropriate and faster. Technically, the second one is the faster operation, and it has to do with the way the variables are looked up in memory and when the assignment is done. It's one fewer operation that has to take place, so plus plus x is marginally faster than x plus plus. However, in business style applications, you're probably never going to see a significant difference between the two. Where it does very much matter is when they show up as part of a compound expression. If I were to say console.writeLine x plus plus, and on the next line I say plus plus x, now it matters very much. When the plus plus shows up as a postfix operator, it will execute that after how it's used in the entire expression. Since x is being passed to the console writeLine invocation expression, to the method, it is going to print x first, then when the console writeLine is complete, then it'll augment x. When it shows up prior to the x as a prefix operator, it will change the value of x prior to the call to console writeLine. Let me end the code with a console read line, so we have something to execute after the write lines, and I'll remove the other breakpoints. I'll hit F5 just to get here. Take a look in the watch window. X is equal to 12 at this point. I will hit F10, and then I'll take a look at the output window. Notice here, it was 12 prior to the call. It prints 12, but look at the value of X in the watch window. It is 13. So it printed out X when it was 12 and then augmented it to make it 13. From what I said before, the plus plus X should have the opposite order. In this case, we are going to change X immediately or prior to the call to console write line, so that'll make X 14, so we should see 14 printed for the next line. And in fact, we do. If you find this confusing, you wouldn't be the first person to feel this way. I like to make my code as easy to read and what I call clean as possible. When you put compound expressions together, or you do these assignment operators or increment or decrement operators within compound expressions, it can get very hard to read and to understand what is the appropriate order. How does this work? What is the value actually going to be? Sometimes you just have to run the code to see what that value is. I prefer not to author my code that way because I find it leads to bugs in the long run, especially when you have other people working on the same code as you, because they may not recognize that the plus plus matters if it shows up as a prefix or a postfix operator and assume it is always going to be modified before it is used in the expression or after it is used in the expression. The same goes if we had X as an R value here when we're passing it to Z. If we run this code, let's just get to that statement. You can see that X is 14. So when this runs, will Z be 14 or 15? Well, it's going to be 14 because remember, it passes X to Z first, then it augments X. Again, if we were to put the plus plus prior to X, now when we run it, initially Z is going to be 14 as we saw before, but it's going to augment X first, which is now 15, so Z is now going to be 16. So it makes a big difference how you write this when used in compound expressions. If this is too confusing, the best bet would be figure out what you wanted Z to be. If you want it to be equal to what X is now, then do it this way. If you wanted it to be equal to what X will be, then do it that way. Now there's no confusion. You know that it's going to augment X prior to the assignment to Z, or it's going to augment augment X after the assignment to Z. Be explicit, be direct. This does not cost you that much in terms of execution, but it provides a lot as far as understandability. What about order of operations? The good news is C# follows the same type of strategy as most people learn in grade school. Some people learned it as PEMDAS, where it's parentheses, exponents, multiply, divide, add, and subtract. Some people learned it as GEMS, where you have groups, in other words, parentheses, E for exponents, then M stands for multiply and divide, and S stands for subtract or addition. Whichever strategy you learned, just be aware it applies here as well. So anytime you have an expression that has a multiply and an addition, the multiply will always occur first. Doesn't matter if it's on the left or the right. If I change this to this code here, it'll execute X times Y first, then do 2 plus that to whatever the answer is, and then add 1 to that result. It would be the same as if I had parentheses such as this. It's the exact same order of execution. Like what I showed or discussed with the increment operator, if you can't figure out necessarily what the order is going to be, just make it explicit. Use parentheses. It doesn't really cost you anything as far as performance is concerned. You might as well use them if it makes your expression clear, because anytime you have a compound expression like this, you have to be fully aware of how the ordering is supposed to work. Otherwise, you are going to get answers that may not match your expectations. And one thing you may be wondering is, how do you do exponents or powers in C#? Well, you can't do them with a single operator, because in other languages you might use the caret operator, and in those languages this would represent x to the power of y. That is not the case. The caret operator represents exclusive OR. So that is not going to give you the same result you would expect from a power operation. If you need to do exponents, there is a math pow function that allows you to pass two values. In this case, it's always expecting doubles, so whatever the result is here, we would have to convert to an int prior to assigning to z. And that brings up a really interesting problem in C#, and that's mismatch types. When you're doing math between integers and doubles, or singles, which are floats, or shorts, we have all of these different data types. How do they work together when you do mathematic operations on them? So if we had z is equal to x times y, there is no issue here because this is all int. What happens if we introduce a double called d, set that to 2.5? This becomes a problem, because it's not that there's a problem with multiplying an int by a double, it's that the result of this is going to be a double, because C# is going to promote the x value to a double prior to multiplication. So we would have to store the answer in another double. As such, now there's no problem. So this, like I said, is known as data type promotion, where a lower or smaller data type is promoted to a larger one so the operation can take place. This is an implicit conversion. Nowhere in here did we say treat x like a double. It is just going to happen automatically, because an int cannot contain all the possible values of a double, so double is considered the larger, or sometimes better, type for storing larger values. So the int x will get promoted to a double prior to the multiplication to 2.5. It doesn't physically change x. It just simply takes the value of x, whatever it is, let's say it's 15, and it'll make it 15.0, a double, and then multiply it by 2.5, and the answer is then again a double. I could replace the 2.5 with the d, and again it's going to give me the same result because d is a double. C# also supports the 6 common equality and inequality comparison operators. And they would be equals, not equals, greater than, less than, greater than or equal to, and less than or equal to. So all of those operators are supported by all of the numeric data types. An example would be, I'm going to define a few more variables, I, and then j, and then we'll do some console write line statements. We'll say I is equal to j. The result of each of these operators, the equals operator or not equals, which is exclamation equal, it always returns a bool value, true or false. And notice to compare using equals is two equal signs next to each other rather than the single equal sign that we've seen everywhere else, which represents assignment. You have to be careful when you use the equals operator, because sometimes C# will detect that what you're doing is incorrect based on your usage pattern. But for instance, if I were to do this I equals j assignment in the process of passing it to a console write line, it's going to detect that this is possibly okay. Where it's not going to like it, if I have a bool variable, this is fine, where it says, is I equal to j? Yes, assign it to b. But if I get rid of that second equals, now it's like I have no idea what you're trying to do because this is an int, this is an int, that's a bool, and I can't do the direct assignment. So in a lot of instances, it will detect the incorrect usage of the equals assignment operator and the equals comparison operator. Just try to be very careful and make sure anytime you're comparing two values, you use the two equal signs, not the single. Then I'll copy this several more times to show you the different other comparison operators. So we have the greater than, less than, greater than or equal to, less than or equal to. So when I run this, we will get a series of trues and falses. You can see the answers. Let me scroll down so we can put them next to each other. So the answer to equals is false. The answer to not equals is true. I is greater than j. 10 is greater than 7. I is less than j is false. If I is greater or equal to j, it's true. I is less than or equal to j is false. These operators, again, will work with all of the numeric data types. And if the two data types can be implicitly compared to each other, then you can also combine them in these expressions. So if I know we have d is a double and I is an int, it is also possible to test them together. I is equal to d. This is again going to do the promotion of I to a double, so it can compare the two values together. It doesn't change I as far as the actual variable itself. It just reads whatever I contains, in this case 10, and then makes it 10.0 just for the life of this expression, just so it can actually do the comparison between I and D. One other thing I'd like to show you as far as doing mathematic operations is that sometimes a data type doesn't support the plus, minus, times, and divide directly. For instance, date times. If I create a date time called now, and I set it equal to datetime.now, datetime.now represents the current date and time whenever it executes, and I'm assigning that to a variable called now. If I wanted to change the value of now, I don't really want to use the plus, because what does plus mean? What am I adding to it? Is it a year? Is it a month? Is it a day? Is it an hour, minute, second? So in those instances, you have to take a look at the data type and see if there are, and there are in this case, methods specific for adding days or milliseconds, years, something specific for that data type. So when I say add years and I say add 10 years, the result is going to be another new date time. Then I can store the result of that add operation back into the now variable. So even though we are doing an addition here, it is not using the traditional add operator. So some data types are like that. String is another data type that supports the actual plus operator, as such, but it doesn't add two values together like 1 plus 2 is equal to 3. For string, the add operator means concatenate. So it will take ABC and blend it together with DEF to make a single string ABCDEF. One thing I did not call out before, which I should have brought your attention to, was that there is a difference between unary and binary operators. If we were to go back up to the code where we do the add, subtract, multiply, and divide, all of these are known as binary operators, binary meaning 2. The operator requires a value on the left of the operator and one on the right. That's what makes this a binary operator. Another operator which I showed was the increment operator, but notice this one only manipulates a single value rather than needing two. This is a unary operator. And there's another one that is very useful, and that would be the unary negate operator. That simply takes whatever it's applied to and flips its sign. So if it's a negative value, it becomes positive, and a positive value becomes negative. The only value that it doesn't do anything to would be the 0 value, because 0 is neither negative nor positive.